Genian can be rapidly deployed using ARP enforcement to block unknown devices by default. First, a policy server is deployed. It can be deployed either on-prem or in the cloud. Cloud options include the Genian's managed cloud or a cloud policy server that can be obtained from the AWS Marketplace and installed on a customer virtual private cloud. The system can be configured to block new devices that are not explicitly trusted. This follows the best practices of the Zero Trust model. No edge switch controller or AP configuration is required. High availability is also not required because the system fails open. The system is truly vendor agnostic, no network dependencies. It can be rapidly deployed in approximately 10 minutes for policy server and sensor, and it supports virtual environments. Once the policy server is deployed, network sensors can then be deployed at various locations in the network depending on the network topology. Network sensors will automatically detect new devices, and any new device that is not explicitly trusted will be blocked by default at its point of connection using ARP enforcement, which again requires no complex network integrations and is suitable for all network environments. Genian can also be configured to provide logical segmentation on any network. This allows network administrators to assign least privilege access to trusted devices, which is part of the Zero Trust model and a best practice. This can be achieved without any complex network integrations. The permissions will follow the device or the user, which is much easier to manage than static network configurations. This is accomplished by defining separate permissions, which will then logically carve out what access each device has while it is connected. You can provide trusted or full access, guest access for internet only, or even some limited internal access only for IoT and OT environments. These are just a few examples, but obviously multiple different permissions can be configured to meet your specific use case. Let's review how you can quickly and easily in a few minutes provide segmentation with Genian ARP enforcement. Step 1 is to define node tags. This allows you to tag specific devices and designate them for certain uses. For example, you could have an employee tag, a guest tag, and some other limited tag. Once you define the tags, you can create node groups. Node groups will match on the previously created tags to group nodes together as they connect to the network. The node groups can then be linked to enforcement policies and permissions. This means that any device that is assigned a tag, matches a group, then falls under the enforcement policy and automatically has the defined permissions applied to the device. You can test and validate to ensure the tagging, the groups, and the enforcement policies work. The important item to remember here is this does not require any network integration, and it is all defined in software inside of Genian NAC. This means no matter where the device travels to, different floor, different building, different campus, wired or wireless, these permissions will follow the device, so the logical segmentation is always intact, regardless of the network infrastructure or network upgrades and replacements. Let's take a moment to review least privilege access and segmentation and why it is so important. First, we'll take a look at legacy privilege access. Historically, access was defined by department or unit. That means that different departments and units would be assigned to a static VLAN on the network. Typically, what this means is anyone in a particular department has the same access as everyone else in the same department. What this means with legacy privilege access is that you have increased exposure and risk. That's because you have a larger attack surface. So if one single user is compromised, then the entire attack surface includes the entire VLAN that user is on. So regardless of where this user resides, if legacy privilege access is assigned, this gives this user and the user's device access to more information than required. So this does not follow least privilege access and creates a larger attack surface if there is a threat. Let's contrast legacy privilege access with least privilege access. Using least privilege access, unlike legacy privilege access, you have dynamic segregation by not only user, but device and compliance status as well. Using Genian NAC, there is no network dependency to perform this segregation. With least privilege access, instead of having access to an entire VLAN, an individual may have access only to one particular server, or maybe even a particular service on that server. With least privilege access, we have reduced exposure and risk. As we can see here, the potential attack surface if a single user or device is compromised has been reduced. Because the user and device did not have access to the entire VLAN, the attack surface is reduced only to the individual's device and then a particular server or even maybe a particular service on a particular server. This greatly reduces the attack surface and mitigates the overall risk and exposure for the network if there is a threat.